Good morning, everybody. I miss you all very much. And Going to use this moment just to tell you what we're going to do in the check-ins, the class after we had homework assignments. So whenever we have homework, specifically problems that involve calculations or structures, I'm just going to right away in the checkout review, or sorry, the check-in, review those problems. Okay, a little bit more traditional than we normally do in class, but hopefully this is helpful. So what I want you to do is open your handbooks up to those problems, starting with silicon dioxide here, and I'm just going to go through each of them and just want to make sure you guys got it right. So valence electrons want here, so that is 24. They all want 8. Valence electrons have, so this is 12, 6 times 2 here, plus 4. Okay, so 12 plus 4 is 16. Subtract those 2 is 8, divided by 2 is 4. So for symmetry, SI is going to go here. Okay, and we're just going to go 1, 2, 3, 4. And everybody has their lone pairs except for oxygen. And again, today's class is going to be about this molecular geometry, so leave that blank. All right, NO2. So what we got here again is 24. And what do they have? Well, we have 12 plus 5 plus 1 more. So that's going to be 16 again. Divided by 2 is 4. Remember, this whole thing is going to go in brackets with a minus 1 at top because that is a polyatomic ion. And O. Now, it doesn't matter where you start. If I start here, I'm going to end up with that there. Doesn't really matter. It can be all over. That's called resonance. And I'm going to give everybody the dots that they need. Okay. H3O plus. Okay. So now I have a different situation because remember, that's an exception. So total 3. Each one wants 2. So that's 6 plus another 8. That's 14. Okay. Minus valence electrons have. So that is 3 plus 6 is 9 minus 1, which is right there. So divided by 2, that's going to give us 3 bonds. It's a polyatomic ion. So we're going to go ahead and do that. And the shape is like this. And you're going to learn in today's class that anytime there's a lone pair of electrons at the top of a center atom, it's going to push these bonds down. Okay? So, and that's going to change the shape to this molecule. This molecule is actually called trigonal pyramidal. So N3 minus, this is azide. A lot of people had problems with this. I'm going to not let you guys do a ring here. So if you did a ring for your answer, I want you to change that. Okay, so again, that's going to be 24. Okay, we're going to subtract that from 5 times 3 plus 1. So that's 16. 24 minus 16 is again 8. We're going to be left with 4 bonds. And let's just put those all in a ring. I mean, in a line. Sorry. 2, 3, 4. So that center N is good. Got to do these. And again, it's a polyatomic ion, azide. That's one of the 8 exceptions. Okay, sulfate. I don't know what that thing is here. So again, that's 8 times 5. All right, so 8 times 5 is 40 minus all of these, what they have. So again, we have 5. They all have 6, so that's 30 plus 2. So 32 divided by 2. That's going to be 4 bonds, and this is the sulfate polyatomic ion. Everybody here has what they need. And it's a polyatomic ion. Got to put it in parentheses, minus 2. And lastly, hydroxide, another exception. So what do they want? O wants 8, that wants 2. 10 minus what do they have? Well, that's 6 plus 1 plus another 1. So that's 8 divided by 2. So that's going to be 1 bond, OH. Now, H is good there, but the O needs its electrons. So go through, double check, and you can jump over right now into the office hours or ask a question on the doc if you got any of those incorrectly.